Hi, welcome to my video on solving trig equations, quadratics part 2. And this one pertains to the GCF, the greatest common factor. Quadratic trig equations. Let's look at trig expressions, which are these, and the algebraic expressions, which are very similar. Let's look at the algebraic expressions. X times y. Degree of x is 1. Degree of y is 1, so the degree of this expression is 2. So cos has a degree of 1, sine theta has a degree of 1, so that's a quadratic expression. In terms of trig, cos squared theta is a quadratic, degree is 2, same as x squared has a degree of 2, sine squared theta has a degree of 2, and y squared is a degree of 2, and these are very similar to these, only these are trig expressions, these are algebraic expressions. Notice each has a degree of 2. Each of these expressions here, these three, are quadratic. Quadratic equations in trig can be solved by factoring. The first rule in factoring is GCF, greatest common factor. We remove the GCF if there is one. Let's do some examples. Cos squared theta subtract cos theta. That's the same as x squared subtract x. So if I take the x out of these two expressions, x squared divided by x is x. X divided by x is 1, and we have a minus. So this is same here. We have cos in this term, cos theta in this term and this term. So cos theta is common. So cos squared divided by cos is cos theta, and cos theta divided by cos theta is 1. So they're very, very similar. This is the algebra factoring. This is the trig factoring. And the same here. We have in this algebraic expression, y is GCF, so we remove it. Yx divided by y is x. 2y divided by y is 2. And same here, only this is in trig. Notice the sine theta is in this first expression and in the second one, so we take the sine theta out. And when we do, sine theta cos theta divided by sine theta gives me cos theta. And 2 sine theta divided by sine theta is 2. Again, very similar. The y here is the same as the sine theta, and the x is the same as the cos. So you can see the similarity in factoring. And if you wish, you can pause your video and factor these. Here we go. Sine theta is common, so we take it out. Sine squared divided by sine is sine theta. Sine theta divided by sine theta is plus 1. In these two expressions, I see a 3, that's common, and I see a cos theta. So I take that factor out. So 3 cos theta sine theta divided by 3 cos theta gives me a sine theta. 12 divided by 3 is 4. Cos divided by cos is 1, so I get it just 4. And in this expression, 2 parts, I see cos theta here and cos theta here, so I take the common factor of cos theta out. And when I do, cos squared divided by cos is cos theta. Cos theta sine theta divided by cos theta is a minus sine. And remember, if you multiply this monomial by this binomial, we should pick up this right here. So sine times sine, sine squared, sine times 1 is sine. Number 4, most common, as I see a cos theta is a common factor. So root 3 sine theta cos theta divided by cos is root 3 sine theta. Subtract 2 cos theta divided by cos theta is negative 2. So that's just reviewing the factoring before we start to solve equations. So let's solve some trig equations, which has GCFs, which is the first rule in factoring. Solve each for theta, and 0 is less than or equal to theta less than 360. So we want the answers in degrees. So we have an equation equal to 0. Cos is a common factor in these two expressions on the left. Cos squared divided by cos is cos. Cos theta divided by cos is plus 1. And we have two factors. Cos theta is equal to 0, or cos theta plus 1 is equal to 0. So cos is the x, so we'll look at the circle. And again, I have this memorized. As I say to my students, I can close my eyes and write this down. So cos is the x, so where's x? 0, and is that 90 and 270. So theta is 90 and 270. Cos theta plus 1, so we move the 1 over to make a minus. Cos is the x, where's x? Negative 1, right here. And that means that theta is 180. So if you took your calculator and did the cos of 180, you get negative 1. And so we put them in order. The answer is 90, 180, and 270. Each of these subbed into this equation right here will give me a 0. B. Now we have an equation, so we have to move all the variables to the left side, which I'm doing. Equals 0, so negative root 3 cos theta moved over to become plus, and I see that there's a cos theta as a common factor. So 2 sine theta cos theta divided by cos theta gives me 2 sine theta, and root 3 cos theta divided by cos is root 3. Now that I have them factored, I have two possible factors. Cos theta equals 0, or 2 sine theta plus 3 equals 0. We practiced this in the first video where we had a product of two expressions and we let each of them equal to 0 because this is a quadratic. Now we have cos theta equals 0. Look up here. Cos is the x is 0 again. We have theta is at the 90 and the 270. But this one we have to solve. So 2 sine theta equals negative root 3. Move it to the right and change the sign. Divide by 2. We have sine theta is negative root 3 over 2. And we got to find the values of theta, so we'll add sugar to coffee. So sine is the y, so y is negative, or sine is negative. So sine is, these are all, and sine, these are positive, so it's in quadrants 3 and 4. So we'll draw the diagrams in quadrants 3 and in quadrant 4. Make the circles a little bit large so we can see. We got to draw the terminal arm in quadrant 3, perpendicular to the x-axis. Terminal arm in quadrant 4, perpendicular to the x-axis. Sine is the y, so that's a negative root 3 over 2 right there. And this is the negative root 3 over 2 there. And opposite root 3 over 2 is a 60. Opposite root 3 over 2, positive or negative, is a 60. And let's write the other ones in. This is a half, but it's negative. That's hypotenuse is 1. That's a 1, but this is a positive half. Opposite of half is 30, and this is 30. But the reference angle for each of these is 60. And we're in the second quadrant, sorry, the third quadrant. So in the third quadrant, theta is 180 plus the reference of 60. So that's 240. And in the fourth quadrant, it's 360 minus the reference angle of 60. So it's 300. So that means the answer for theta, for all of these, we put them in order. We got a 90. We have a 240. We have a 270. and we have a 300. Now, I put them in order. Again, when the teacher goes to look at them, teacher might want them in order. You have to check with your teacher on that. So let's continue. And now we can do some practice, and practice means pause the video and see if you can work these out yourself one at a time. Here we go. Solve for theta. 0 is less than or theta less than 360. That means I want the answers again in degrees. So is equal to 0. I see a cos theta common. Take it out. So cos theta sine theta root 2 is root 2 sine theta minus cos theta divided by cos theta is 1. Oh, I didn't need this one. I got that one there. So that means we have cos theta equals 0, or we have root 2 sine theta minus 1 equals 0. And again, we need cos is 0, so we have 1, 0, 0, 1, negative 1, 0, 0, negative 1. Cos is the x is 0. A couple of times now we've seen this to be 90 and 270. X is 0 here, that's your 90. And x is 0 here, that's your 270. And we got to solve this one for sine theta. So we got a root 2 sine theta equals 1. Move the negative 1 over. Divide both sides by root 2. So we have sine theta is equal to 1 over root 2. They cancel, so we multiply by root 2 over root 2 because we have the rationalized denominator. 1 times root 2 is root 2. Root 2 times root 2 is 2, because root 2 times root 2 is root 4, which is a 2. So we got these answers done. Now we have to do this one. So, add sugar to coffee. Sine is the y and is positive, so that's in quadrants. Positive in quadrant 1, and it's positive in quadrant 2. So we draw the terminal arm in quadrant 1, perpendicular to the x-axis. And we quadrant 2, we draw the terminal arm, perpendicular to the x-axis. And because we have a root 2 over 2, the y is root 2 over 2, because sine is the y is root 2 over 2, and automatically, if you have a triangle, this is a 1 and a 1, and this is root 2 over 2. This side here is negative because it's the x, root 2 over 2. This is a 45-degree reference angle because it's a 45-45 right triangle. So in this triangle, this is first quadrant, so the angle in the first quadrant, the reference angle is theta, which is 45. In the second angle, second quadrant, it's 180 minus the reference, so that's a 135. So theta is 90. Oh, well, let's scratch that out. Let's go with the 45 first to put them in order, then the 90, and then the 135, and then the 270 to keep them in order. So instead of putting the 90 first, put the 45 first. And we have another one to do. Again, pause the video and see if you can work this one out. We have a quadratic. A quadratic has to be equal to 0 because we have the x squared. So 2 sine squared theta plus sine theta equals 0. Move the negative sign over to the left to become positive. And I see a sine theta common. So 2 sine squared divided by sine is 2 sine. And sine divided by sine is 1. So we have two factors. We have sine theta is equal to 0. Or we have 2 sine theta plus 1 equals 0. And we got sine is equal to 0. So again, that's on this circle as a 1, 0. 0, 1, negative 1, 0, and 0, negative 1. So sine is the y. Where is y? 0. And that's at 0 degree. And is also at 180. Notice, if you look at, it's equal to 0, but not 360. Yes, 360 all the way around also is an answer, but we can't take it because the domain is from between 0 and 360, equal to 0, but not equal to 360. And go down here, I got to solve for sine theta. Move the 1 over, make it a minus, divide by 2. So sine theta, 2's cancel, is negative 1/2. And where we're going to, again, add sugar to coffee. Sine is the y, and the y is, sine is positive in 1 and 2, so it's negative in 3 and 4. So it just takes a second. In quadrant 3, it's negative, sine, terminal arm, perpendicular. Quadrant 4, terminal arm, perpendicular to the x-axis. And again, sine is negative, quadrant 3 and 4, and sine is the y, so the y is negative 1/2, the y is negative 1/2, the hypotenuse is 1, 1. This side right here is root 3 over 2 negative, and this side here is root 3 over 2 positive. Opposite the half is 30, opposite root 3 is 60, and that's the same here. Opposite the half is 30, 60, so the reference angle for this rotation is 30 degrees. Because we're in the third quadrant, theta is 180 plus the reference of 30, so that's 210 degrees. And because we're in the fourth quadrant, we got 360 minus the reference of 30, so that's 330 degrees. So we have them all done and put them in order. We got a 0, we got a 180 next, we have a 210, and we have a 330. And again, any one of those subbed into for theta here, both sides will come out to be equal. And we have another one to do. Okay, a little bit of manipulation here. Again, don't forget, pause the video and see if you can work it out before I do. Here we go. We have it equal to 0, so we'll multiply, get rid of the brackets. So 1/2 times 4 is 2 cos theta, and 1/2 times 2 is 1, and cos times cos is cos squared. So that's the first bracket. So that 1/2 cos theta is multiplied by the 4 and the 2 cos theta. When we subtract, we add on the opposite, or you can think about making that a 1 there, make that a negative 1, and multiply by the negative 1. So that makes negative 3 cos theta minus 2 sine squared theta equal to 0. And we simplify. We have the cos's. Let's do the cos squared first. I just write them down so you can, and we have a 2 cos theta minus 3 cos theta. There it is. I group the squares together, so it gives me negative. That's a 1 minus 2 is negative cos squared. And I have 2 subtract 3 is a negative cos. And I can take the negative out, or I can divide, multiply everything by negative 1. So I get cos squared theta plus cos theta. 0 times negative 1 is 0. Now I can remove the cos theta because it's common. Cos squared divided by cos is cos. And cos divided by cos is 1. So we get cos theta equals 0. Or we get cos theta plus 1 equals 0. That means that cos theta equals negative 1. And we're on the circle again. Again, this one is 1, 0, 0, 1, negative 1, 0, 0, negative 1. And if you were doing a quiz needing this trig, it's best to write this at the top of a sheet of paper somewhere where you can see it all the time. Notice I'm writing it down each time, but if you wrote it down on a quiz or keep it on a sheet of paper where you can see it all the time, then you wouldn't have to, especially on a quiz, write it down all the time. Cos is the x, whereas x is 0, and theta is the 90 and the 270. And cos is negative 1. Cos is negative 1 at the 180. And so we have them all, put them in order, 90, 180, 270. And again, these are all the angles that when you sub them in here and work it out, you'll get a 0. And that brings us to the end of this video, showing you how to factor quadratics which have a GCF. And the GCF is the first rule in factoring. Don't forget that. The first rule in factoring is remove the GCF if there is one. And if you like my video, click the like button. And if you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.